Again, welcome to Database Management System course. In these lectures, we're going to cover the entity relationship model. This is one of the common model that is used in database design process. Again, entity relationship model, also called entity relationship diagram. So our main objective is to go through what we call the ER model concept. Again, ER is the entity relationship, ER model concept. So we're going to discuss about what is an entity's attributes and entity types, the value set, key attributes, what is a relationships and different types of relationships, also a weak entity types, also roles and attributes in relationship types. We're also going to discuss about the ER diagram, the notation. We have two types of notation. We will go through both of them. So first, what is an entity relationship model? Here we say first of all, we discuss about what is a model. So a model can be a representative of a complex, real-world complex system in terms of a diagram or an equation. So entity relationship model, and again, it's a graphical representation of entities and their relationships in a database structure. So again, designing a database system, the most common tool that we always use is the entity relationship diagram or a model. There are so many applications that make it possible for us to come up with the entity relationship model. So again, entity relationship model is the graphical representation of entities and their relationships in database structure. So entity relationship diagram is the uses graphic representation to model the database components. So a database components normally consists of entities and then relationship types. Then within the entities, we have the characteristics of the entities, which will be the attributes. Then within the attributes, we may have the data type of the attribute, whether it's a primary key or secondary key or a candidate key, etc. So first, we should know what is an entity relationship model, which is a graphical representation of entities and their relationship in a database structure. Entity relationship diagram, again, uses a graphic representations to model database components. So entity instance or entity occurrence will be the rows in a relational table. A row in a relational table will be one record. For example, a relational table we mean consists of rows and columns. So a column will be one attribute of an entity, and one row will be again one record or one from data about one entity. Also, attribute describe the particular characteristics. In a relational table, the attributes will be the columns. Then connectivity will be the term used to label the relationship types. So here we're going to discuss about entity relationship model. And the main component of entity relationship model are the entities and the relationships. Entities normally will represent it by noun. For example, a person, a product will be an entity. Then the characteristics of the entity, for example, a person may have address, last name will be the attributes. Relationship, we have three different types of relationship. One-to-one, one-to-many, or many-to-many. Relationship make it possible for us to connect two or more tables or relational tables together. So this is an example of a ER model notations. As we said earlier, we have two main types, which is the chain notation and also the crown's feet notation. The reason why it's called the crown's foot notation, we can see the many, we have something like a crown foot. So let's start with the chain notation. As we said, we have three different types of relationship. With the chain notation, the diamond symbol will be the relationship type. And always the relationship will be a verb. Like here we have a paints, learns, manages, and three type of relationship. Here we have one to many, many to many. Many to many is M and N. Then one to one. And as we said in our previous lectures, we normally generate the relationship from the business rule of the organization. So with the chain notation, our boxes are called the entity and the diamonds are the relationship. And the type of relationship we will see either one, M or N. So example of the first, we have a painter paints painting. So the business rule said one painter paints many painting. So painting is an entity. Painter also is an entity. Another example here, we say many employee learns many skill because this is M and N, which is many to many relationship. So many employee learns many skill. Always the entity will be a noun and the relationship always is a verb. Here we have one-to-one, which we're saying that one employee manages one store. One employee manages one store. So this is the chain notation. And we can see the crown-field notation the same, but here also we say one painter paints one or many painting. Many to many, we can see both crown-field again, it's both sides. So many employee learns many skill. And here we have one-to-one. The two bars or the two lines are one. So one employee manage one. And also we have the object-oriented programming concept, the class diagram. So UML is one of the main tools that we use to model so many different types of software applications. We have up to like 14 to 15 different diagrams. In software engineering, we use the UML diagrams a lot. Here we are going to use only the class diagram. So UML stands for Unified Modeling Language. And here, when we're using object-oriented database system, we can have a class diagram. So here we have a class named Painter, which is our entity. Paints, painting, one-to-one. And also it can be one to many, many to many, etc. So we have employee, skill, employee, and store. And this is again a class diagram. So we talk about the object-oriented data modeling. Here we say both the data and its relationships are contained in a single structure known as an object. So in object-oriented programming, we know we have a class. A class normally consists of the data members and the method that are going to be performed on that very particular class. So object-oriented database management is based on, again, object-oriented concept. So object contains the data and their relationship with operation that are performed on it. In our programming, we will say object consists of data members and also the operations that can be performed on it, which will be the methods. And the same concept here contains data and the relationships with operations that are performed on it. So the basic building block for autonomous structures and also the abstraction of a real-world entity. We said the attributes normally would describe the properties of an object. Most of the time we say it's the characteristics of an object. So example of an attribute, let's say for student, can be the student last name, address, the student grade. These are all the attributes, the characteristics of the student. So a class normally is a collection of a similar object with shared structure and behavior organized in a class hierarchy. So when we're doing the object-oriented programming, it's the same concept. The class will be the blueprint of an object. So if I have a class named vehicle, from class named vehicle, I can create car 1, car 2, car 3, get any amount of car using the class. The class will consist of the data members and operations that can be performed on. So class hierarchy is again resemblance of an upside down tree in which each class has only one parent. And the concept of inheritance means one object can inherit methods and attributes of classes above it from its parent. And also Unified Model Language, UML, describes set of diagrams and symbols to graphically model a system. And we have different types of diagram. Here we are discussing the class that only the class diagram. We have a sequential diagrams and so many of them, somewhere around 14, 15 diagrams. We also have activity diagrams, class diagram, of course, and use case diagram, and so many of them. For example, use case diagram show the model how users interact with the system. Activity diagram will show a model what type of activities the system will perform. So this is the object-oriented data model. We can see our classes, object representation, the UML class diagram. We have customer, invoice, and line. And the invoice, we need customer and a line. Then if this is again object-oriented concept using the class diagram. So we have the class, each class will be consist of data members and attributes. So you can see the invoice, they show the data members, which is the attributes. Then the behavior, in this case, we deal with the relationships between the attributes. Between the entities. Attribute is the characteristics of the entity. So invoice is an entity, customer is an entity, relationship between the two. But invoice number, invoice date, these are the attributes or the characteristics of the invoice table or entity. Then we know the year diagram. Here we are using the crown fit. We have our entity. Our relationship is vet. So here we say customer generate. One customer generate 0 or 1 or more invoices. And here also we have one invoice has many lines, one or many lines. So object relational and also XML, we have what we call the extended relational data model, which support the object-oriented features and also extensible data types based on classes and inheritance. Then object of relational database management system are based on, again, extended relational database model. An extensible markup language, which is the XML, uses to manage unstructured data for efficient and also effective exchange of structured, semi-structured, and unstructured data. And then emerging data models, at the moment, we're talking about big data, then also the NoSQL. The goal of a big data is to find a new and also the better way to manage a large amount of web and sensor-generated data, or provide higher performance at a reasonable cost. The big data normally consists of the 3 V's, which is the volume of a big data is very high. Velocity means the speed of generating the data is very fast. And variety means this is a large data and we have different formats or different types of data generated at the same time. Also, challenges of a big data will be the volume. These data are very huge, large, so we need a special algorithm to handle it, and also we need a special application to again store it, because this data cannot be stored as a relational database system, because here we have online data which is generated in different formats and unstructured. So to save this data in relational database will be difficult. So those are some of the challenges. Very expensive. OLAP tools prove inconsistent dealing with unstructured data. The volume doesn't allow usage of conventional structures such as relational database, etc. So the new technology for handling big data. Mostly this will be in data science courses. It's using distributed system such as Hadoop or Hadoop distributed file system, MapReduce, NoSQL. This is again new technology that we normally use to handle big data. Spark also does a good job. Spark. So NoSQL database, here we say not based on relational model. So we don't need to use, that's why it's called NoSQL, because it's not based on a structured model like a relational model. Also support distributed database architecture, such as Hadoop system. Also provide high scalability. Here we're dealing with a high volume of data. So the scalability up to very high. Also higher variability and fault tolerance. Also it supports large amount of sparse data because most of these data are generated live, stream, video, etc. Geared toward performance rather than transaction consistency, and also provide a broad umbrella for data storage and manipulation. So in summary, we can see the evolution of data model. We start with in 1960s, we start with the hierarchy. Then by 1969, we have the network. With the hierarchy and the network, it's very difficult to represent many-to-many relationship with the hierarchy alone. The structural level dependency. Also, null and hardcore queries, record at the time access. Then in 1970s, relational database started. This was again developed in IBM lab in early 1970s. Conceptual complexity, conceptual simplicity, and also provide the hardcore queries such as SQL. Then we have the entity relationship, easy to understand, more semantics, limited to conceptual modeling. Then within the semantic, we have object-oriented, then extended relational model. Then by 2009, the big data where we use the NoSQL. This addresses big data problem, less semantics in data model, based on schema, less key value data modeling. So the hierarchy models, these are some of the advantages. It promotes the data sharing. Parent-child relationship promotes conceptual simplicity and data integrity. Also, data security is provided, and these are enforced by the database management system. With the hierarchy model, it's very efficient with one-to-many relationship types. Now, the disadvantage can be it requires, of course, a knowledge of physical data characteristics. So navigational system require knowledge of hierarchy path. Changes in structure require, again, changes in all the application programs. Implementation limitation, no data definition, also lack of standards. The network model, the advantage can be the conceptual simplicity. Very easy to, again, grasp the concept. And also it handles more relationship types, all the three relationship types. And data access is very flexible. The data owner or member relationships promotes data integrity and also conformity to standards, including the data definition language and data manipulation language. The disadvantage for network model will be the system complexity normally limits the efficiency, and also navigational system yields complex implementation, application development, and management. Also, the structural changes will require changes in all the application program. So this is, again, very important disadvantage. With the relational model, the structural independence is promoted using independent tables. Also, we know it's a tabular view improves the conceptual simplicity. With the relational model, again, everything is a table. We know we are used to table, rows, and columns. So make it more easy to understand. And also ad hoc query capability. which is based on SQL, also is provided. And also isolate the end user with the physical level details, improve implementation and management simplicity. Disadvantage with the relational model will be it requires, again, substantial hardware and system software overhead. And also conceptually simplicity gives untrained people the tools to use a good system poorly. Also may promote information problems. So next we go to the entity relationship model. Entity relationship model, we say again, is a visual representation of a real-world database system, and is very, very good for communication, efficient. So it's a visual model, yes, conceptual simplicity. Also, the visual representation make it an effective communication tool. Also, it's integrated with a dominant relational model. Disadvantage with the YIHA model will be it has a limited constraint representation, and also have a limited relationship representation. No data manipulation language. Also, loss of information content occurs when attributes are removed from entities to avoid crowded displays. With the object-oriented model, the advantage will be semantic content is added. Also, it's a visual representation, includes semantic content. Inheritance concept can be promoted for data integrity. Then disadvantage can be slow development of standard, cause vendors to supply their own enhancement. Also, complex navigational system. Learning curve is very steep, and high system overhead slows the transactions. With the non-SQL, we say the advantage will be, of course, scalability. Non-SQL is normally for data science, big data. So high scalability, availability, and also fault tolerance are provided. Also, it uses a low-cost commodity hardware. Also support the big data. Key value model improves storage efficiency. The disadvantage with a non-SQL will be complex programming is required, such as the Hadoop map reduce, and there's no relationship support. Also, there's no transaction integrity support. Also, in terms of data consistency, it provides an eventually consistent model. The degree of abstraction too is very important. So here we can see the end user view, we have the external model. Before that, then we have conceptual model, which is the designer's view. Then we have the logical independency, then the physical independency. So we can see the pyramid degree of abstraction from high to low. High is the entity relationship, object-oriented. Medium will be the relational. Then low will be the network hierarchy. So with the external model, the end user view of their data environment. Here we can say that people use the application programs to manipulate the data and generate information. Also, the ER diagrams are used to represent the external views. An external view is such as a specific representation of external view. So this is our external model for a college named Tiny College. So this is the registration system or student registration. We have a student may take up to 6 classes per registration. So we have one student enroll in one or many enrollment. And also class is taken by enroll or course generate class or class generate course. And then this conceptual model also can represent a global view of entire database by the entire organization. Conceptual schema, again, is the basis for the identification and also high-level description of the main data objects. Then logical design, tasks of creating a conceptual data model. So a conceptual model advantage can be the micro level view of data environment, software and hardware independent. So here we have internal model for tiny college. We have the conceptual model professor. Conceptual model, we don't really care about the attributes of the entities or data type. So we have a professor, class, room, and course. When we say one professor teaches one or many classes, we can say one room is used for one or many classes. And also one course generates one or many classes. So the internal model here, we can create a table named professor. Then we specify the characteristics, which is the professor ID, last name, initial, first name. The data type is set. Then we create a second table named class. The attributes are class ID, course ID, professor ID, room ID. And we specify the type. Course ID will be a primary key field, and the type is number. Then we create a table name room. So we have a room ID, room type. Then we create table course ID, course name. So the internal model will representing the database as seen by the database management system, mapping conceptual model to the database management system. We have the internal schema, which is the specific representation of an internal model using the database constructs supported by the chosen database. In logical dependency, we say changing internal model without affecting the conceptual model. And hardware dependent will be unaffected by the type of computer on which the software is installed. The physical model normally operates at a lower level of abstraction. In any computer system, physical level is always the lower level of abstraction. This will describe the way data are saved on the storage media, such as magnet, solid state, or optical media. And with the physical model, it requires the definition of physical storage and physical access method, both software and hardware dependent. The relational model again aim at logical level, and this normally does not require physical level details. So these are some of the levels of data abstraction for physical model. We have the model, degree of abstraction, focus, and independent of. So external will be a degree of abstraction will be very high. And also it focuses on the end use views, can be the hardware and software. Conceptual will be the medium high. It's a global view of data, database modeling independent. And it's based on a hardware and software. Internal will be the medium low, which is a specific database model, and also it's the hardware. Then the physical will be the low, degree of abstraction will be low, the storage and access method. And this is neither the hardware or the software. So in summary, in these lectures, we went through what is a data model again. Here we say a data model is an abstraction of compressed real-world data environment. When we talk about compressed real-world data environment, again, we went through the most important concept here, which is the using the ER diagram to design our data model. So there are many different types of data model. Higher ranking, we talk about the advantage and disadvantage, the network, relational, object-oriented, extended relational data model. So data modeling normally requirements are a function of different data views, either global versus local, and the level of also the data abstraction. So this will be the end of our lectures on entity relationship model, and wish everybody the best. Thank you.